sea somewhere waiting for me.
We are on lesson 7 of unit 7. So we just completed a lesson, on solving proportions and then using solving proportions to do scale models and scale drawings. So now that we've done scale figures, we're going to kind of use that same idea but apply it to a geometric concept. Now this is the first geometric concept we've done. We haven't really incorporated a lot of geometry throughout this year, but I'm going to start to incorporate a little bit more just because I think we're getting to the point where we're starting to feel comfortable with the algebra part of it. So now we're ready to start incorporating some of the geometry that can be included with pre-algebra. So this one's about similar figures. And so the key word there being similar. So they're going to be almost the same, but not quite. And the part that's going to be the same is the shape of it. So if you look at the two rectangles I have, they're relatively the same shape. Now I am a human, so I may not draw them exactly the same. But they are supposed to have relatively the same shape. But if you notice, one is a whole lot smaller than the other. So one is probably about a quarter of the size of the other one. And so they're not the same size, but since they're the same shape, we would call these similar figures. And all similar figures are going to be proportionate. So this is kind of where this all falls into the same unit that we've been working on with ratios and proportions, is that similar figures are proportionate. Think about it. If you were to have a piece of clip art on Microsoft Word, and you expand the figure. So if you're on the computer and you have an image, and you drag the corner of the object, a lot of the times it'll stay the same, it just gets bigger, right? We're just kind of expanding it, we're dragging and dropping. And so that's what we're doing here. We're essentially, you can view us, if I had my mouse, if my hand was my mouse, I would click on this corner and expand it out until it was the exact same thing as this. So that's what we're looking at here with similar figures. Now I'm going to talk about something called corresponding parts. So corresponding parts are parts of a figure, or excuse me, parts of two figures in the same position. So if I have two triangles, okay, so we'll have triangle X, Y, Z, and then we have a similar triangle P, Q, and R. Triangles are similar. Notice my really large angle, the one that's here, Q, so we say angle Q is similar, or is in the same position as angle Y. Then kind of going off of that, if we go in this direction, that means angle P would be similar or in the same position as angle X, and then angle R would be similar or in the same position as angle Z. So those little L shapes are what we represent with angles. So since this is the first geometric thing we've done, I'm introducing you into some of this notation. So this little figure here, this little L shape, like I said, looks kind of like the greater than or less than symbol, but it's the angle symbol. So anytime we're talking about one of our corners or angles, we're going to use that shape. So angle Q and angle Y are in the same position. If you look, they're the same angle, they're the really wide one, and they're in the same position with each other relative to the two different figures. Then you could say that this side would be this side, because if Y and Q are together and R and Z are together, that means this side and this side are in the same position, this side and this side, and the long side. So for now, we're going to keep these looking the same. Eventually we're going to get to a point where I might start flipping some of the shapes around. For now, I'll keep them in the same relative location, or relative position, so we can kind of figure out which ones are corresponding. So let's take a look at finding missing measures. So we're going to use this idea of being proportional. Okay, so I give us two triangles. We'll just call this ABC and DEF. Actually, I'm going to get rid of the title up here. Okay. So if we have these two triangles, and I tell you that A, so I'm going to mark that with one thing, and D are the same, and then B and E are the same. So notice they're corresponding because we're told the number of arcs inside of it are the same. So because that's the same, that's the kind of indication that you're looking for to say that A is the same as D, B is the same as E, and C is the same as F. Once you know that, now we know that they're similar, and now we know that we have corresponding parts. And so now they're going to look at us and they're going to tell us that this one is 4 centimeters, this one is 12 centimeters, this one is 6 centimeters, and they want to know how many centimeters are on that side. Well, like I said before, these two figures are proportionate. When we have two similar figures, the figures are going to be proportionate. So I'm going to get rid of this. Leave that copy down. And this is going to be very similar to when we had things where we said, like I think we had an example with plums the other day, where we said like 6 plums for $1, and then we wanted to know how much it cost for 10 plums. So when we do that, we kept 6 and 1 together, because it was $6 for 1 plum, and then it was 10 plums for we didn't know how much money. So we're going to do a similar thing here. You want to keep the triangles together in one fraction. So we would have 4 centimeters and 6 centimeters. And that's going to equal, now remember, we want to keep them consistent. So 4 gets paired with the 12, so those both go on top, then the x and the 6. And now we have a proportion. So the one triangle formed one fraction, the other triangle formed the other fraction. Both of these sides were corresponding parts, the 4 and the 12, and the 6 and the x. Again, remember, we cross multiply. So 4 times x gives us 4x. 6 times 12 gives us 72. And then when I divide both sides by 4, it is going to be 18 centimeters. And so that's what we're looking at here, and the application that's going to happen with the proportions and the similar figures. So we're going to look at some additional examples, and I think in class I'll kind of give you a printout of the particular rule that says this applies. So we're going to look right now just at applying it and how that works. And then in class I'll give you kind of the formal theory definition printout that will incorporate this. So, similar to triangles, we can also apply this to other shapes. As long as we know the shapes are similar, we can apply this to any two shapes. So if I have Call this example 2. So if I have a rectangle, another rectangle, and I tell you again, these shapes are similar. So if we're given that, now rectangles can be a little trickier because the angles are all right angles. They're 90-degree angles. So we're not necessarily pairing these off just because angles are the same. Because notice, they're all the same. So now it's more based on, it's going to be easier for rectangles also because you can just look at it and know this one pairs with this one pairs with this one. Other than that, we know these two are both the same, so it doesn't matter. Can I put this one with this one? Yes. Can I put this one over here? Or this one with this one? Those small sides all are proportional. And then the long sides, again, are also all proportional. So rectangles is a little less rigid in terms of how we line things up. It's more on just make sure the short sides are with the short sides and the long sides are with the long sides. So, if I tell you that this one we have 5 centimeters and then B centimeters, and we have 30 centimeters and 24 centimeters. So again, they give us 3 of the 4. So we're going to keep things consistent. So we're going to put the 5 over B. Okay, so you still keep them within the same shape. Now the 5 is the long side, so it goes with the other long side of 30 over 24. Again, we cross multiply. So I get 30 times B is equal to 5 times 24. It's going to give us 120. When we divide by 30, we end up with B is equal to 4 centimeters. And you can kind of test that. 5 times 6 gives us 30. So if I take 24 divided by 6, what should I get here? I should get 4 centimeters. So this is the idea that we're looking for here. With using proportions and solving similar figures. So I'm going to go ahead and give you guys 2 more sets of similar figures, just for some independent practice here, that you'll solve. And then, as usual, I will give you the answers afterwards. You can check your work. And if you need to correct it, make sure that you do correct it. Alright, I'm going to go ahead and start giving you the answers. You again check your work. I know I tricked you up a little bit on example number 4, so when we get there we'll see if you followed along and did the right thing there. Alright, so on this one, we line up the 28 over the 49, and that equals, again, 28's on top, so 7 goes on top, and the x will go in the denominator. So remember what I told you is that you can simplify this before you actually solve. So if I were to simplify this, I can divide them both by 7, so we end up with 4 over 7 is equal to 7 over x. Then we cross multiply, so I get 4x is equal to 49. We divide by 4, so x is going to be equal to 12.25 centimeters. Alright, on this next one I gave you 3 side lengths, and I changed the position of the shapes. So I know I tripped you up a little bit on this one, but I think you guys are capable. So let's take a look. Now I'm missing this one here. So notice which one this pairs to. It pairs to the 7. So we know we're going to want to incorporate this 7. It doesn't matter. You get to pick one of the other sides to use. So I'm going to pick the long side. So if I do x over 36. So I pick my missing side and the long side. I could do x and 27, that's okay too. Then I'm going to relate that to 7 over 12. Then I cross multiply. So we end up with 12x is equal to 252. When we divide by 12, we end up with x is equal to 21 inches. You would get the exact same answer if you lined up with the 27 and the 9. That would be okay as well. Alright, we will talk about this a little bit more in depth. Tomorrow we'll do some additional problems and we'll practice more of this switching around and what that looks like and how shapes are similar, and we'll take a little bit of deeper look at this tomorrow in class.